Hi everyone, this is JC1 H2 Mathematics, and in this video we'll go through tutorial 1 on integration techniques, and we'll go through questions 12, 13, 14 and 15. Okay, so it's really due to time constraint that we have to do this on video lah. Okay, so let's get started, shall we? Okay, on question 12, okay, let's read this together. So using the substitution, x equals to tangent theta, find the exact value of this integral, right? Definite integral. So we can calculate and like evaluate lah. What is the final answer? Okay, so in this question, right, usually this would be given. So like the idea on integration by substitution, right, is that they will give us the substitution to make it easier for us to integrate. So it's not always where we have to automatically apply the substitution method, even though some questions can use substitution, okay? But usually we reserve those with substitution, right, for the very last thing, because usually that's what they will give. Okay, it's when it's really no choice, then they will give, then we will use integration by substitution. Okay, so with this right over here, when we do integration by substitution, we need to replace three things. We need to replace, what is this? The L, the E, and the D. So we need to replace the limits, we need to replace the expression, and at the end of the day, we need to replace the differential. Okay, so these are the three things that we need to replace. Okay, so first, so let's start with okay, so letting x to be equals to tangent theta. Okay, so let us do some replacement. So let's differentiate. So dx d theta would be equals to secant square theta, right? So let's have it over here. So dx would be equals to secant square, okay, secant square theta d theta. So this is the differential. Okay, this one over here is the differential that I'm going to replace, and then the expression, right, will be from here lah. Okay, x equals to tangent theta, so like that. Okay, then what about the limits? Okay, limits, right, over here, when at 0, at 1, right, we will need to try to replace. Okay, so when x is equals to 0, okay, so tangent theta is equals to 0, so theta would be equals to 0 as well. Okay, so making use of the making use of inverse tangent, so theta will be equals to 0. Okay, then when x is equals to 1, okay, so tangent theta over here is equals to 1, so theta will be equals to 45 degree, so it will be pi over 4 radians. Okay, so these are some things that we'll need to set up before we integrate. So now I think we're prepared to integrate, right, from 0 to 1 minus x square over, okay, 1 plus x square dx. Okay, so now let's do the replacement. Okay, so I will replace 0 and 1 with 0 and pi over 4. Okay, so let's replace this. Now then 1 minus x square, so I will have a tangent square theta. Okay, next one down there, I will have a 1 plus, okay, x square again, so tangent square theta below, whole thing square, and then dx, I will need to replace this with secant square theta d theta. Okay, so whole thing like that. Okay, so let me do some simplifying, right? So on top, right, I think there's nothing much to simplify yet, so I will just let it be, or maybe I can try to make it to secant square, because for tangent square we cannot integrate directly, so maybe I'll try to get the secant square out first. So this one over here, I'll replace this with a secant square theta minus 1. Okay, so where is this from? This one is actually from the identity, right? Secant square equals to 1 plus tangent square theta. Okay, so this one is the identity. Okay, because we cannot integrate tangent square lah, so we'll need to change it to secant square to integrate. Okay, so how do I know that I cannot integrate, right? Is actually how I see this later. Okay, over here 1 plus tangent square theta, over here 1 plus tangent square, I can actually change this one below to secant square. And then I still have a square. And then on top over here, I still have a secant square theta d theta. Okay, so miraculously over here, if you can see, right, the one at this bottom over here and this term, this and this will cancel nicely. Okay, if you can see this. So after that, I will have something like this. Okay, so I will have a 2 minus secant square theta divided by secant square theta d theta. Okay, now it doesn't really mean much like this, so let's try to separate it out. Okay, so I will separate this out from 0 to pi over 4. So separate meaning like 2 over secant square theta minus secant square over secant square will give me just a 1. Okay, all right, so now 2 over secant square, sorry, yeah, correct, 2 over secant square, actually this one is 2 cos square theta minus 1. Okay, now we cannot integrate cosine square directly, so what can we do? We have to change it back to cosine 2 theta. We have to make use of the double angle formula over here. So means, right, this one over here, I need to change this to, okay, the double angle formula is cos 2 theta, like that. Okay, d theta. Okay, so this one over here, okay, I made use of the double angle formula. Okay, so something for us to take note. Okay, so I think this one will be very neat already, very easy to integrate already. Now, so at this stage, right, do we need to, because it's easy to integrate, do we need to change back to the original variable? Don't need, we just evaluate straight away. Okay, so for this one, we just evaluate straight away. So cosine 2 theta, it will be just half sine 2 theta. This is what we integrate into. Okay, and then half is a scalar multiple, so I just put it outside and I will evaluate from 0 to pi over 4. Okay, so with this over here, this will be half. Okay, put in the pi over 4, this will be 1. Then put in the 0, this will be 0. So the whole value is just half. Okay, so mainly just like that. Okay, so integration by substitution, right? For definite integrals, so we have to change LED, all right? And because this is a trigo question, so we need to be very flexible to see what are the domains that we are integrating on, so that we can get the correct angle, and at the same time be flexible in our use of the identities and also double angle formula to change the expression so that we can integrate better. Okay, so it looks like there's a lot of change over here, right? But it's really a lot of foresight, because you just need to know, you need to remember that, okay? You need to remember that tangent square cannot and cotangent square, right? You cannot integrate directly. You have to change this to secant square and cosecant square theta directly. Okay, so there's something for us to take note. Okay, as we simplify and try to evaluate trigo integrals. Okay, so that's all for question 12. Okay, so let's continue with question 13, part A. All right, so find the exact value of P such that, okay, we have this expression on the left equals to another integral on the right. Okay, so what do we do, right, is let's try to observe. Now, the one on the left, right, we can actually find the value, right? The one on the left over here, we can actually find the value. We can actually integrate and find the value. The one on the right, where there will be a P over here that we will need to take care of. So I think let's do this separately. Let's not do this whole big thing one shot, because there is obviously more work to be done here. So we're going to just evaluate the left-hand side first to see what we get. Okay, so over here, okay, we have from 0 to 1 of 1 over 4 minus x squared dx, like that. Okay, so this one, right, we have to recognize the pattern now, all right? So this one is the a square minus x square formula. So if you refer to your MF27, okay, if you refer to the MF27 over here, okay, this one is making use of MF27. Okay, let me write this in red. Okay, you'll find that actually it fits the formula for the ln one. Okay, so over here, what do we have? We have 1 over okay, 2a, which is 1 over 4. Then I have a ln of okay, the formula is 2 plus x over 2 minus x, like that. Okay, so mainly like that. Then integrating from 1 and 0. So this 4 over here, right? So this is a square is equal to 4. So a, right, will be equal to 2 lah. Okay, we'll take the positive root for this one. Okay, can. So for this one over here, right, let's take a look at okay, so let's take a look at how do we, oh sorry, this one over here. I think better just put a equals to 2 lah. Okay, okay, now all right, so with this, let us try to evaluate. Let's sub in 1. If we sub in 1, right, if we sub in 1, this would be ln 3. If we sub in 0, this would be ln 1. Okay, this is going to be ln 1. Then this one over here is actually 0. So on the left, right, we actually have 1 over 4 ln 3. Okay, so this is the value on the left hand side. Okay, so let's now try to integrate the right hand side. Okay, so integrating the right hand side, right, this one over here. Now because we want to also fit the formula for the MF27. So because when this is a square root, right, obviously this would need the tangent, no, sorry, this would need the sine square lah. Sorry, sine inverse for us to integrate. Okay, but before we integrate, right, we need to take note. We need to make the coefficient of x square to be equals to 1. Okay, and how do we make the coefficient of x square to be 1? Which is we need to factorize out the p square first. So how do I do that, right? Okay, you see, so 1, 0 to 2p, 1 over 2p. Now, taking out the p square, okay, so over here, right, if I take out p square, okay, so I will have a 1 over p square minus x square, like that, correct? So this will be at the bottom, like that. Okay, like that, like that. Oops. Okay, dx, like that. Okay, now then because of product, right, over here, this step over here, right, so let's say if I have square root a and b, I can separate it to root a and root b, correct? So what I will do is I will just split the p square out. Okay, so this one I will have 1 over p times, like this, 1 over p square minus x square, like that. Okay, dx. Okay, so this is the one that I made use of the okay, the product of the surds. Okay, so with this, right, p is actually a constant multiple, correct? So let me bring the 1 over p out over here. Okay, the next step over here is, now then I think we can integrate this function already. This one, right, you recognize the pattern, it should be sine inverse, correct? So this one over here should be sine, oops, this should be sine inverse of x over 1 over root p. Okay, from 0 to 1 over 2p. Okay, so something like that. So x over a, all right, and of that thing over there. Okay, so with this, right, now I have a 1 over p on the outside. Okay, next thing is I will need to tidy up first. So when I tidy up, I have sine inverse of px, like this. Okay, now so let's try to evaluate. Okay, so first I have sine inverse. Okay, so put in 1 over 2p, right? So I have a sine inverse of half. Okay, then next I will have a 0 over there, so minus sine inverse of 0, and this value over here which will also be 0. Okay, now sine inverse of half. Okay, which angle when we multiply will get sine inverse of will get sine of the angle equals to half? The angle is 30 degrees, so this is pi over 6. So altogether this is pi over 6p. Okay, so altogether, right, because both of them are equal, left and right, they are equal, right? So this thing will be equals to this thing over here. Okay, so putting it all together, okay, 1 over 4 ln 3 is equals to pi over 6p. Okay, so p will be equals to 4 pi over ln 3, 6 ln 3. So altogether, this would be 2 pi over 3 ln 3. Okay, so that's the answer for question 13 part A. Okay, it looks a bit weird because you have pi and ln in the same expression, right? But this comes from the fact that yeah, it's a whole process lah, like that. Okay, so this is something for us to take note. Okay, something for us to take note. Okay, so this is for 13 part A. Okay, so 13 part B, okay, use integration by parts to find the exact value of that thing dx. Okay, so what I want you to do is, because when we are integrating by parts, right, especially with limits, right, my advice is we just integrate first without limits. Okay, integrate first without limits, so that when we sub the limits, right, we can do it one shot at the end of the day. Okay, so now the question is, how do we find the integral of ln x squared dx? Okay, so over here, right, because ln x squared itself, because there's nothing here to guide us, right, so we make use of the clue that the question gave us. We use integration by parts. Okay, so this means that we are going to integrate by parts, and we are going to expect an invisible 1 over here to be our partner lah, of the integration by parts. Okay, so let's try to write out what is the u and what is the dv dx. Okay, so which one will take the u, which one will take the dv dx? Now, preference from u, right, we actually look at liate, correct? So let's look at the L first, the logarithm one. So over here, u will be our ln x squared. Okay, ln x whole thing square. So this one, I want you to be careful. Okay, so this one over here. Another thing to be careful is this is, okay, be careful. This is ln x whole thing square versus ln x square. So be careful. Okay, so two are completely different things. Okay, so u will be ln x whole thing square, dv dx will be 1. So differentiate left hand side, I will get 2, okay, 2 ln x over x. Okay, this is the left hand side. Okay, then on the right hand side, integrate this, I will get x. Okay, so next, so what do? We will take uv minus v du dx. Okay, v du dx. Okay, so with this, u times v, so this is x ln x square minus integration of 2 ln x over x multiplied by x times dx. Okay, so let's simplify this a little bit. Okay, so over here, I put the 2 outside, I will get a ln x dx. Okay, now same thing for ln x dx, right? This one over here, I will also need to integrate by parts, because I think this one is something that you need to be aware of. For special functions like ln, inverse, trigo, we can do integration by parts straight away. So over here, I'm going to make u to be ln x again. Okay, and then dv dx to be equals to 1 again. So du dx would be 1 over x. V, when you integrate, become x. Okay, so once more, let us do this. So x ln x squared minus 2 times of, okay, uv minus v du. Okay, so this one I have a x ln x on the side minus 1 over x times x dx. Okay, so this one over here will be x times ln x squared minus 2x ln x minus x plus c. Okay, so this is the whole whole process of integrating by parts. Okay, all right, so with this, let us finally put in the limits. So from 1 to e of ln x squared dx, so this one would be the whole expression, right? put in the e and the 1, correct? So this would be x ln x square minus 2x ln x minus x plus c. The c don't need to put in already, from 1 to e. Okay, so let's sub in e first and let's see how does it look like. So we have e and ln e squared, correct? Then minus 2e ln e minus e. Okay, then we put in the 1, so minus 1 times ln 1 square minus 2 times 1 times ln 1 minus 1. Okay, so let's evaluate all the ln e's and the ln 1. So ln e is 1, ln e is 1, ln 1 is 0, ln 1 is also 0. Okay, so these are simple results that we need to know. Okay, so with all this in mind, so we have e minus 2e minus e, then we have a plus 1. Is it? Okay, sorry, my mistake. I have a 2x over here, 2x over here, 2e, and a minus 2. Okay, so altogether, this one would be minus 2e minus minus will be plus, 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 plus. Okay, then at the end of the day, this one at the back over here will be minus 2. Okay, so with all of this will be e minus 2, like that. Okay, so once again, I have an error over here. I had an error over here, error here, error here. Okay, so because this one over here, negative, negative will give me plus 2x. Okay, so like that. Okay, cool. So once again, you see that it's actually more convenient to integrate first without the limits. Okay, then only then at the end, just bomb all the limits one shot. Okay, and then we can sub in and do the evaluation right away. So be very careful. So same thing also, be careful of the double negatives. Okay, be careful, things of times 2, right? Don't be like me. Okay, so be very careful when you're doing integration. Okay, how do you know that you're doing correctly? You can just differentiate to get back what you need to get. Okay, so this is for 13 part B. Okay, let's move on to 2005. Okay, question 14. Okay, so state the derivatives of sine x squared and cos x squared. Cool, so very easy. Okay, so when we differentiate the function of sine of x squared, okay, so this one is mainly using chain rule. So we have cos x squared multiplied by 2x at the back. So this one would be 2x cos x squared. Okay, same thing over here when we want to differentiate our cosine of x squared. Okay, so differentiate cosine will give us sine, negative sine. Okay, and differentiate the x squared will give us 2x. So this will be negative 2x sine x squared, like that. Okay, so using these results over here, we are going to find, okay, the integral of x cubed cos x squared dx. Now obviously if you see this, right, because there's an x cubed and a trigo, there's an algebra and trigo, right? And if we double check, x squared, x cubed, there's no relation. We cannot differentiate the x squared to get x cubed, right? So what we'll do instead is we will do integration by parts. Okay, so because it doesn't fit the f prime, okay, so we will then consider integration by parts. Okay, so how do we integrate by parts? Now first, following the LIATE, okay, we prefer the a to be the u, this one over here to be the dv. So means that this x cubed is u, cosine x squared will be the dv lah. Okay, the derivative. Okay, so that's in the trigo to be the dv. Okay, so with this over here, let us try to figure out what is u is x cubed. So when we differentiate u, this would be 3x squared. Okay, next for v, this is dv dx is equals to cos x squared. Okay, and then we are stuck, right? We are stuck, right? Because, right, if we integrate, do we have any results from integration? No, we only have results for the derivative, right? So what do we need to do? Okay, so this is us need to be able to work backwards. Okay, so let's observe. we have the results that we can integrate back to this side. Okay, so over here, right, it actually makes more sense for us to split the x cube to something that we need. Okay, so instead of starting with u and dv, okay, let us start by splitting this to x square x cos x square dx like this. Okay, so that you see we can fit this format over here that we can integrate by parts, because we can make use of these results to integrate back to this. Okay, so this one, right, so let's change our u and dv. So our u over here, right, this is going to be x squared, differentiate to become x. The dv dx is actually x cos x squared. So when we integrate back, now because we have a 2, right, we have to divide by 2. So half of sine x squared, like that. Okay, do you see that? Can, so this is something that we need to be careful. So if you're stuck, right, think again, think deeper. What did we do earlier in part 1? How can we use the results in part 1 to help with my part 2? Okay, so this one is really your critical thinking skills, okay, and your observation skills. Okay, so with this over here, let us try. So we have uv, so this is going to be half x squared sine x squared, okay, minus of, okay, then this one half of, so it will be uv minus v du, correct? So multiple of this, right, will be half x sine x squared dx. Okay, very nice. You see that this now is sine x squared over here. Very nice. Okay, so do we still need to differentiate by parts again? No, integrate by parts again? Actually, no need. We can just integrate this straight away. Okay, can, so with this over here, so let us try to integrate. So we got half x squared sine x squared. Okay, then minus of half of, now integrating this back to the original expression, this will be half cos x squared. Okay, then at the end of the day we'll plus c. Okay, so this is how we handle part 2. So you see the working actually not long. Okay, it's really not long, but it's up to us to open our eyes and see this expression. Okay, can, so this is for part 14, A1 and 2. Okay, moving on to part B over here. Okay, so find the derivative of sine inverse x and that one. Okay, so d dx. So let's try to differentiate this whole bunch of things over here. Okay, plus x, 1 minus x squared, like that. Okay. Okay, so now let's differentiate, try to differentiate. So differentiate sine inverse, make use of the MF27. Okay, so we have a 1 over square root of 1 minus x squared. Okay, so this one over here, MF27. Okay, or you can just remember lah by heart. Okay, next one, this one over here, this is product rule, so we differentiate carefully. So plus, okay, plus, okay, differentiate the x, then we keep the right hand side over there. Okay, then plus, okay, keep the x, and then we differentiate this. How do we differentiate this? Half 1 minus x squared power negative half. Okay, then will be negative 2x at the back. Okay, next step. Okay, so next step, what do we do? Let's tidy up. Okay, so we have 1 over, okay, square root of 1 minus x squared plus, okay, so 1 minus x squared over here. Very nice. Okay, so let's combine everything to have a minus, minus, okay, x squared over this. Okay, can we see this? Now, let's combine the denominators, right? The same denominators, let's combine them together. Okay, so I don't do this simply, I just combine carefully. So I have a 1 minus x squared on top, okay, over this. Okay, combine carefully. Don't need to make everything the same subject. Okay, just combine carefully and observe. Okay, observe. So we have one full thing divided by the root of this thing. So if you see, right, actually, root 2 over 2, square root 2, right, divided by 2 is actually 2 and 2, correct? So if you cancel, it will be 1 over this. Something like this, right? Okay, so let's do the other way around. So what about if we take 2 divided by square root 2? Okay, so this one over here, right, root 2 over root 2, correct? Cancel, cancel, so I'm left with root 2, right? So we take one full one divided by the square root of the one at the bottom, you see? So this one will give us square root of 1 minus x squared, like that, plus square root of 1 minus x squared. Altogether, this is 2 times of 1 minus x squared, like that. Okay, so this is how we get the first part. Okay, so the differentiate this. Now, hence or otherwise, evaluate the exact value of this. So making use of the answer, we try to integrate back to this one over here, right? Because you see, we already have this one. Very nice. Okay, so very nicely. Okay, so I is equals to integrate from 0 and half following the question, okay, of 1 minus x squared dx. Okay, so I need the half. Okay, I need the 2 from the previous question. So I need the 2 to be over here, right? So because of that, I will need to balance it with a half in front, multiply by half in front. So then half, right? Now let's try to integrate. Let's connect back. So this is sine inverse of x plus x times 1 minus x square square root whole thing from 0 to half. Okay, so let's evaluate this slowly, step by step. Okay, so let's put in the half first. Okay, so over here I will have sine inverse of half. Okay, so later we need to find out the angle. Okay, plus half. Now 1 minus 1 over 4 square root. Okay, so over here, right, this one is going to give me 1 minus 1 over 4. So it's 3 over 4. Correct? So this is going to be root 3 over 4. Or more like root 3 over square root 2. Okay, so this is the first part. Okay, second part, put in the 0 over here. So I have sine inverse of 0 plus 0 lah, like that. Okay, very easy. Okay, so let's try to simplify. Okay, half. Okay, first one, sine inverse of half. Which angle will give us half? Sine angle equals half. So which angle is that? This angle is 30 degrees, pi over 6. Now the next one over here is going to be root 3 divided by 4. Then sine 0 is 0. Okay, so this value is 0. And the one at the back is also 0. So we have like that lah. Okay, half of this. So altogether, expanding the half, so you'll get pi over 12 plus square root 3 over 8. Okay, so this is the final value for I. Okay, can so okay, so something like that for I. Okay, moving on to question 15. Okay, so we want to evaluate this expression over here. Now this expression has a modular sign. So with modular sign, we need to be a bit careful lah. Okay, where here's the domain given. Okay, so in this domain, for this domain, giving an answer in terms of A. So that means our expression will have A, okay, in the expression. Okay, all right. So with this, right, let us try to visualize first, because when we want to integrate graphs under modulus function, right, we need to get the graph out first, okay, so that we can see which area are we integrating. Okay, so over here, this is an a square minus x square graph. So means what kind of graph is this? This is a quadratic graph, specifically a negative quadratic graph, and the y-intercept is at a squared. So I'm going to sketch this first. Okay, so let me sketch this out. Okay, so I will have a negative graph over here. Okay, negative graph over here. Now this value over here, this is a squared. Okay, now next detail to take note, because this is a modulus graph. Okay, so that means this will take the positive version, y equals to a square minus x squared. Okay, now then comes the next part. The next part over here is we will flip. Okay, we will be flipping this graph, right? Correct? Because originally the graph goes downwards, correct? However, for a modulus graph, it will be flipped upwards. So what branch is this? This branch would be y equals to the negative version. So this is x squared minus a squared, right? This one over here is also y equals to x squared minus a squared. Okay, then the next thing is what are our roots? Okay, so when a squared minus x squared equals, okay, so when y is equals to 0, okay, x square is equals to a square, so x will be equals to plus minus a, correct? So this means that here I have a root at negative a, okay, and I have a root at positive a, okay. Now, and then they give us a is in between 1 and 4, correct? So means that our 1 will be here, our 4 will be somewhere here lah. Okay, so when we're integrating, right, between 1 and 4, what does this tell us? It means that we will be integrating for the area under this part and for the area under this part. Can you see? Okay, so it will be very helpful to sketch out instead of just evaluating or trying right away. Okay, get an idea of what we're trying to solve first. So this is actually part of critical thinking lah. Okay, all right. So you see that we're actually integrating under two different areas. So we're going to integrate under the purple area, and we're going to integrate under the red area, the red curve over here. Okay, so let's start to do this. Okay, so from 1 to 4, a square minus x square dx. Okay, so this means that we will be integrating now, looking at the using the concept from area under graph, we'll be integrating from 1 to a of the purple graph. So a square minus x square dx. Okay, so under the purple graph. Okay, step 1. Step 2, we are going to integrate from a all the way to 4 of the red graph. So red graph is x square minus a square dx. Okay, so now let's put our integration to the test. Okay, so integrate first one. A square x minus x cubed over 3 from 1 to a. Okay, next one over here, x squared power plus 1 divided by new power and then minus a square x. Okay, because a is a constant, so we need to put in the x. Okay, like that. Okay, next, let us sub in our a and the different other constants. So I'm gonna get okay, a cube minus a cube over 3 minus a square minus 1 over 3. Okay, put in the a, put in the 1. Okay, next one, I'm also going to put in 4 and a. So putting in 4, right, I have 64 over 3 minus 4a square. Putting in a, I got a over 3 over 3, a cube over 3 minus a cube, like that. Okay, so let's expand and let's try to simplify. Okay, so expanding this, so a cube minus a cube over 3 minus a square plus 1 over 3, be careful, plus 64 over 3 minus 4a square minus a cube over 3 minus a cube, a plus a cube. Okay, so something like that. Okay, so let's add all the a cubes together. So a cubes all together, we have 4 over 3 of them. So 4 over 3 a cube. Now a squares, I have negative 5 of them, so negative 5a square. Then all the other constant terms will be plus 65 over 3. So this is how we will get the final answer. Okay, so you just expand, slowly calculate. Okay, so this right here is example 15. So over here is really not difficult, right? What we need to do is to know that we are going to integrate the graph under two parts, okay? Under the original graph and under the reflected part. And the reflected part will take the negative version of the curve. Okay, so this will be question 15. Okay, so as a bonus, let us head to question 17. Okay, because I feel that question 17 is something that we need to learn also. Okay, so show that this integral will be equals to this whole thing over here, where c is an arbitrary constant. Okay, so means that we will just integrate e power negative 2x cos x dx. Okay, so now this one over here, right, because this is exponential and trigo, and we notice that these two variables over here no relationship. Okay, one more time. So this one over here, no relationship. So what we'll do is we will be making use of integration by parts. Okay, so which one is u, which one is v, actually doesn't matter. Yeah, actually it doesn't really matter lah. Okay, so for this case itself, because it's easier to differentiate lah, it's easier to differentiate this e, so I will just let this be u. Okay, and then this one will be dv. Okay, so let's write this at one side. So over here u equals to e power negative 2x. So du dx over here, this would be negative 2 e power negative 2x. Okay, then dv dx over here, this is equals to cosine of x. So v equals to sine x. Okay, very nice. Okay, so let's start the integration process. So this is uv minus v du. Okay, so uv over here, this is going to be e negative 2x sine x. Okay, minus, okay, negative 2 e negative 2x sine x also dx. Okay, so what I'll do is let me take out the 2. Let me simplify the minus minus 2. So this will be plus 2 on the outside. Okay, then let me do this next round over here. Okay, next, we have another thing that we need to integrate by parts, right? So same thing over here. Let me choose this to be u. Let me choose this to be dv to be a bit more consistent. Not that one is more right than the other one, but it's just to be consistent lah, and to be easier. So u will be equal to e power negative 2x. Du dx would be negative 2 e power negative 2x. Okay, then dv dx, this is sine x. So v will be equals to negative cos x. Don't forget the negative. Okay, so next, let us integrate. So e power negative 2x sine x plus 2 times of, okay, so uv minus v du. Okay, so uv would be negative e negative 2x cos x, then minus, okay, negative negative will become positive, so 2e minus 2x cosine x dx. Okay, so let us expand and simplify. Okay, expand, so this one will be minus 2 of this. Okay, and I have a minus 4 of this over here. Okay, now, so I think after this step, right, you can really imagine, right, because we still need to go through integration by part again, right, you realize that actually it will be never ending lah. Okay, it will be really never ending. So what we do is actually you can just spot that this and this, right, they're the same terms, correct? So what we can do is I will move this over here. Okay, I will move that over there. Okay, so all together, right, minus 4 move to the other side, I have 5 on the left. So 5 of this thing on the left, okay, will be equals to the rest on the right. Okay, now over here, because I integrate already, right, so technically I need to plus C1. Okay, something like that. Okay, so now with the 5 on the left, right, I just need to look for one copy of it. So I just need to divide whole thing by 5. Okay, so over here I have 1 over 5 e power negative 2x sine x minus 2 over 5 e power negative 2x cos x plus, okay, so 1 over 5 c1, I will rewrite this to become just a c, which is just another constant that we don't know. Okay, so like that, we can end the question here like that. Okay, so once more, if you find yourself in exponential and trigo, there is a potential to go on forever and ever. So this is something that you need to recognize. Okay, and the second thing that we need to do is once you find that this term over here, right, is repeating with this term, right? So instead of going on, okay, instead of going on forever and ever, we just lump them together into one common term. Okay, then we divide by 5 to get what we want. Okay, so this is how we handle question 17. Okay, so hopefully in this video is a bit long, but hopefully you take the time to digest all the small details that we need to think of when we integrate, be it by parts, by substitution, right, using trigo, using rational functions, so and by substitution with limits also. Okay, so this one just be very careful lah when you do this. Okay, so with this video, hopefully you'll be able to learn well and progress well. Okay, so that's all. Okay, so see you in the next one. Okay, if you have one. Okay, bye bye.